Problem 6 is as follows. In an air-filled rectangular waveguide, a TE mode operating at 7 GHz has EY is equals to 5 sine 2 pi x by A multiplied with cos pi y by B multiplied with sine omega t minus 14z volt per meter. Determine A, the mode of operation, and B, the cutoff frequency. So, the first part of the problem, finding the mode, is as straightforward as it can get. Remember the standard formula for all of these fields. If you look up the textbook, you will find that EY would have some constant and followed by a sine m n pi x by A, a cos n pi y by B. Now, what the m and n here mean is they are the mode numbers. Okay, so mn could be 0 1, 1 0, 1 1, 2 0, and stuff like that. So if you can find the similar expression here, so the constant is 5. The constant is 5. We have a sine term with m pi x by A, where m is equals to 2, so this becomes m, and the cos term, cos n pi y by B, here there is no n, which means n is probably equal to 1, and the rest is the time domain equivalent. So basically the mode of this particular question is, as a consequence, mode m comma n is equals to 2 comma 1. So it's a TE21 mode. TE is already given in the problem. We are just saying that it's a TE21 mode. Now the next question is, find the cutoff frequency. We know the formula for cutoff frequency is 1 by 2 square root of mu epsilon multiplied with m by A whole square plus n by B whole square whole root. Okay, so this is the formula for the cutoff frequency. But the problem is, we know what epsilon would be because it's an air-filled rectangular waveguide. Mu and epsilon would be equals to mu would be equal to mu naught, epsilon would be equal to epsilon naught. So those things are resolved. M is 2, n is 1, but we don't know what A and B are. So that's not given in the problem. But what we are given is, in the problem, we see that there is 14z here. Now, what is 14z? It's actually beta z. Beta z is 14z, right? So how do we find the value of cutoff frequency from what we already have here? Let's remember the equation for beta that we used in problem 3 to derive the maximum average power per unit width or average power per unit width. So the formula for beta is equals to omega square mu epsilon minus h square, where again h square is equals to omega c square mu epsilon, and omega c is equals to 2 pi fc, and the formula for fc is already here, right? So let's rewrite beta is equals to omega square mu epsilon minus omega c square mu epsilon square root. Now once I take mu epsilon common, omega square omega c square, I pretty much have this as the resulting equation. We know that mu is equals to mu naught, epsilon is equals to epsilon naught, so square root of mu naught epsilon naught is equals to c. So then as a consequence, therefore beta is going to be equal to 1 by c square root of omega square minus omega c square. So we don't know what the cutoff frequency is. We need to find that out. We know what omega is, we know what c is, we know what beta is. That means beta square is equals to 1 by c square multiplied with omega square minus omega c square. So beta square c square is equals to omega square minus omega c square. Therefore, omega c square is equals to omega square minus beta square c square. Omega c is equals to omega square minus beta square c square whole root. We know that omega is 2 pi 7 into 10 to the power 9 whole square minus beta square is 14 square, and c is 3 into 10 to the power 8 whole square. So that's going to give you 43.78 into 10 to the power 10. So Fc is equals to 43.78 into 10 to the power 10 divided by 2 pi is equals to 6.968 gigahertz. That's it. Thank you.